In today's lecture, we're going to talk about something called the OSI model, and the OSI model stands for the Open Systems Interconnection Reference Model. Now, what's interesting about this is that this is a model that we use as a conceptual framework, and it's designed to show us how networks work and how data moves across the network, but it was never implemented. So the interesting about this is that it was developed to guide us through how a network operates, but it wasn't implemented. In fact, another model was implemented, and that model is the TCP/IP model. And we introduced some of the protocols in that suite. So, getting back to the history of networks, a long time ago, people were competing to develop a model to build networks off of. And one group developed the TCP/IP, another developed the OSI model, and when it all came down to it, they decided to go with the TCP/IP model. However, we do use the OSI model because it is a great framework to really show how networks operate at a very high level. And so we use it to teach people, we use it to reference how we're going to design networks, and we also use it to troubleshoot networks when we're having issues. So let's go ahead and let's take a deeper look at it. So what it does is it breaks down the communication process across a network where you're communicating from one computer to some other device on the network into 7 different distinct layers. And what it's composed of are upper layers and lower layers. And the upper layers are considered what we call the host layers. And the bottom layers on the flip side are what we consider the media layers. So what's interesting about this is that when we're talking about host layers and media layers, we are talking about the host computers. And when the media, this gets back to, remember we were talking about physical connections and physical protocols, we're talking about the media. When we're talking about the lower layers, we're talking about the network operations. And so let me go ahead and get my drawing tool out so I can go ahead and mark this up a bit to help it make a little bit more sense. So when we're talking about the network portion, what we're really talking about are the network-centric functions like routing, addressing, and flow control, so things like that, things that operate within the network. When we're talking about the host layers, we're talking about stuff that actually goes on in the computer itself. So we're talking about the application programs where they're interacting with the network. We're talking about setting up the encryption in the software. Then we're talking about data formatting. So for example, when you open up your internet browser and a bunch of data comes over the network into your computer, your internet browser is going to take that HTML and all that other stuff and output it in a manner that you can understand. So let's go ahead and see what it looks like. And like I said, it's composed of those different layers. And when we're talking about those different layers, we have our host layers at the top. We have our media layers at the bottom. So this is what's taking place at the network down at the bottom. And this takes place at your computer. Now, I don't want you to get worried about the details in this lecture because we're going to spend a lot more time talking about the OSI model. So this is just going to be your introduction. So I'm just going to briefly go over what the layers are, but we're not going to get into all the details. We'll do that later on in a later lecture. So when we're looking at this, what happens is that data starts and what it does is that it adds on layers of information. And at the top, it's nothing but raw data where it interacts with an application. And then once it goes down the layers, this data is then segmented and created into what we call segments, packets, frames, and bits. And by the time it goes all the way down from the application to the actual network cable, then it's broken up into actual bits of data. But at that point in time, there's all sorts of information added on. And for example, if we need to encrypt it, then the encryption's added on. If we need to set up a communication, the communication's set up. If we need the communication to be reliable, we can have different protocols that are reliable or unreliable, then we can set that up as well. And then of course we need to know where it's going, so we have our destination address and our source address. So we have our IP addresses and our MAC addresses. And then once it gets down to here, it's really the physical communication. We send it out across the network. And that's really how it works. Now, when a computer receives it, instead of going down, it has to go up. So when it's receiving it, it's going to go all the way up, and it's going to go into this application, and then it's pretty much going to do the exact opposite process of going back down. And this is going to make a bit more sense. I'm going to go ahead and show you a representation on the next screen. But before we get to that, there is one thing that we can use. A lot of people like to come up with different phrases to understand and remember this. And a really easy one here is, please do not throw sausage pizza away. And what you'll notice is that the first letter aligns with the first letter of all these. So for those of you that want to get into networking and you want to take certifications such as the CCNA or the CCNT or the Network Plus, you're going to have to understand and memorize OSI model. And so having these little phrases here is going to be an easy way for you to memorize that. So please goes with physical, do goes with data, not goes with network, throw goes with transport, sausage goes with session, pizza goes with presentation, and lastly, away goes with application. So if you remember little phrases like this, like please do not throw sausage pizza away, or programmers do not throw sausage pizza away, it's a really good way to memorize these layers because there are 7 of them to memorize. So now let's go ahead and jump to the next slide. And this is really going to visualize this whole process that we were talking about. If person A over here, and we'll just say A, wants to communicate with the file server and he wants to send a file and save it onto there, then everything starts here where he types it in. Everything starts here where he's typing it in on his computer. And then when he saves it and he chooses the file folder that's on the file server and he says, I want to save it there, it has to go down all these different steps here from step 7 all the way down to 1 to make that data prepared to go across the network. Now again, we're not going to talk about what all these different things do here. We're going to talk about that in separate lectures, so don't worry about all this detailed information, but just understand that it has to go down. And really what happens is it goes down, it goes all the way down, and this here is the network cabling, goes across the cabling and all the way across the cabling to the file server and back up that stack and into here. And when I'm talking about stack, I'm talking about all these different layers in the OSI model. Now, like I said, this is a conceptual framework and it was never fully implemented. However, it is really close to the TCP/IP. So when we talk about the TCP/IP model, it's going to make a lot more sense because the layers are going to coincide. Not everything is going to be 100%, but it's going to be close enough so we can understand what's going on. So let's go ahead and jump to the next slide. And this is going to be the last slide for this lecture, and we're going to just quickly talk about some of the benefits that we get from using the OSI model. And so let's think about it. It's a reference model. We never fully implemented it. We use it as a guide when we're designing networks. We use it as a guide to teach people like I am to you. And we use it as a guide for when we are troubleshooting networks. So what are the benefits? Well, the first one is that it reduces complexity. If we're breaking down the way that a communication works and how we understand it across the network, then it makes a lot more sense when we break it up into 7 discrete layers versus if we have no layers at all and we're trying to explain it. So when we break up the communication into smaller parts, it's easy for us to understand. Now, another thing is that it standardizes our interfaces and it standardizes the way that different components are going to communicate from one device to another. So when you have multiple different vendors creating different applications, different devices, and so forth to communicate across the network, you need a model. And this model helps standardize the way that they understand how they can communicate, simply because this is so close to the TCP/IP model. Another thing too, because since we allow this standardization, then we also allow for the ability to have modular engineering. So what do I mean? Pretty much think about plug and play. So if you think about the PC world, if you've ever built a computer, you can get a motherboard from one vendor, you can get a CPU from another one, you can get a hard drive from another one, you can get a memory from another one, and so forth and so forth. And so when we talk about modular engineering, it means that we can have all these different vendors making all these different devices communicating together. So you can buy your router from one vendor, you can buy your switch from another vendor, you can buy your network cabling from another. If they're all following the same standard and the same rules for communication, then we can have modular engineering. And that leads us to the next point. Because we have that, then it allows for interoperability between these different types of technologies and these different vendors. And that leads us down to our final point. When we bring all this together, we have a reduction in complexity, we have more standardized interfaces, we have modular engineering, and we have interoperability between different technologies and vendors. Overall, it really accelerates the evolution of the networking world and the IT world. And so for those of you that are familiar with Moore's Law, this will make a lot of sense because, the way that the IT world and the way that the computer industry and everything in regards to technology, the way that it has evolved over time is just amazing, and it's much faster than anybody could have guessed. And when we're using models like this, it really accelerates evolution because you can have a lot more updates. You're going to have a lot more improvements across these different vendors working separately and working together. And so it just really improves it all. So anyways, that's going to go ahead and conclude our lecture on the OSI model. Like I said, I just want you to have an understanding of what it is, why we use it, and a brief understanding of how it operates in this lecture. You don't need to worry about memorizing all the different names of the layers or what they do at this point in time. I just want you to be familiar with it. We'll get into those details in another lecture. So thanks for watching, and we'll see you at the next lecture.